This week we talked about linear equations and exponential equations. So we're going to talk about graphing them and writing the equations of their lines. Okay, the first one I just wanted you to review. And is it linear or exponential or neither? It's going to be linear if our patterns add or subtract, which would be on the y-coordinates. It's going to be exponential if it multiplies or divides for the y-coordinates. And it's neither if it does some kind of combination of both. So for linear, once again, it always has to add or subtract. Exponential always has to multiply or divide. So if we look at our first example, you should be able to see it's always adding 5. So that means this table is linear. Let's come down to the second table. You can see that I'm multiplying this times 10 to get 100, and then 100 times 10 to get 1,000. So that means that this would be exponential because I'm always multiplying. Now if we looked right here, it looks like I'm always adding 1. But you have to look at your x-coordinates as well, because since I'm skipping, that means that I'm not adding 1 consecutively to each number in my term. So this would be a neither problem. So once again, linear because I always added. This was exponential because I always multiplied. And this is neither because it doesn't really do both consecutively. It's not always doing something. This is a copy that we did in our class, or a copy of the notes, and you should have this written down in your notebook. If not, you can pause the video and you can write what you need to. But the key word for word problems for linear are per and each. The key word for exponential are doubles, triples, quadruples, anything that insinuates I'm multiplying. Now, here's the most important part, which is the two equations. And linear equations are something we did in 8th grade. And that's just your normal y equals mx plus b. Now, since this is a function, though, if I wanted to write f of x right here, I could. All right, exponential, this is the function right here. That's the equation. F of x, and we could write y just as easily, but since it's a function, we're going to notate f of x, equals, and this is your formula, a times b to the x. Your a is always your y-intercept, or the initial value. Your b is always going to be what we call the constant quotient of change. That just means what is your ratio. Now, one thing I want you to notice is that I have parentheses for the formula, but you don't have to put parentheses if you don't want to. In fact, if you don't want parentheses, you could write the problem as f of x equals a times b to the x. So you could either keep parentheses or not. It's up to you. Your a is always your y-intercept. Remember that, your initial value. And your b is your constant ratio. Okay? Now, the graphs of linear compared to exponential. Linear graphs, of course, make a straight line, and they're always either increasing or decreasing. Exponential graphs, we called them our ballerina graphs whenever we did our dance in class, because it's like you're just being a ballerina with your hands. But it either is growing, that's called exponential growth, or decaying. Growth happens if your b is greater than 1. Decay happens if your b is less than 1. All right? And that makes sense. Your b is never going to be 1, because if it was 1, it wouldn't be growing at all. It'd be staying the same. So if b is greater than 1, if it's bigger than 1, then it's growing. If b is less than 1, then it's decaying. All right. And then we're just going to practice writing some equations from the tables. So for a linear function, remember our equation that we start off with is y equals mx plus b. And this is just like 8th grade. So what I want to do first, I need to figure out what is my m. So I just choose any 2 points. So to find my m, I subtract my y's over my x's. Remember, it doesn't matter the order you go, as long as you go the same order on the top as you do the bottom. So -6 over -1. So my m would reduce to +6. So that's my m. All right, now to figure out where my y and my x are, all I do is just pick a point. So I'm going to pick the point 1, 5. That's what I'm going to use. So I got to plug in my m into this equation, and then I'm going to plug in my x, and I'm going to plug in my y. So your equation would be 5 equals m times x, which is 1, plus b. And then you just solve for b. Now that we have b, and now that we have m, I can go ahead and write my final equation, which is y equals mx plus b. But plus b, this is going to be -1. All right, I did have some steps that I listed just to remind you. So if you would rather have steps, here are the steps, but once again, you should know the process more than anything. But the first step would be you have to find your slope. Your second step is you're going to plug x, y, and m into slope-intercept form, which is y equals mx plus b. Third thing you do, solve for b. And then the fourth thing is you plug or you substitute m and b back into y equals mx plus b. So this is the 4-step process that you're going to keep doing. Okay, I'm going to move on to exponential functions, which is our next example. And I know it's exponential because, look, I'm always multiplying. And I'm always multiplying by 3. Y'all see that? Okay, my function for an exponential equation, this is what it's going to look like. And actually, I should have said my equation for my exponential function. Sorry. But my equation is f of x equals a times b to the x. A is your y-intercept, and b is going to be your ratio. I personally always like to start off with what is my ratio, because I think that's the easiest. So I'm going to write this down. Now my ratio is whatever I'm constantly multiplying by. And you can see I'm constantly multiplying by 3. So I'm just going to write 3 to the x. If you want to put parentheses, you can. If you don't have to. No big deal. The second thing we have to find is our y-intercept. Now, when we're looking at a chart, our y-intercept is always where x equals 0. That's where our y-intercept is. But do we have x equals 0 in our chart? No. But can we figure out by looking at the pattern what it should be? Yes. So let's just look at our pattern. We're going to continue it. And if I'm always multiplying by 3, then in order to get my next number or my previous number, I'm not going to multiply by 3. I'm actually going to divide by 3. So 3 divided by 3 is 1. So this would be your y-intercept. And a way to check yourself, you should be able to multiply each previous term by 3 to get the next number in your chart. So 1 times 3 gave me 3. 3 times 3 gives me 9. 9 times 3 gives me 27. So I have the right y-intercept. And your y-intercept, you only use the y-coordinate. And you're going to put that in for a. So this right here is the equation. I want you to notice exponential equations are way quicker or way faster to write than linear equations. Exponentials is pretty much what you see is what you get. There's no solving for any values, except maybe you might have to figure out the y-intercept. So let's do a few more. Okay. And I have this exponential function, so write this one. As you can see, it's constantly multiplying by 5. All right, that's why it's exponential. So I'm going to start f of x. This is just my formula, a times b to the x. B is always what you multiply by, so times 5 to the x. And a is your y-intercept. So to figure out your y-intercept, we look for where it's 0 on the chart. Do you see 0 on the chart? No, so we need to find it. So if I go by my pattern, that would be 0. Take a second by yourself and see if you can figure out what the matching y-coordinate would be. If you said 1, you're correct, because instead of multiplying, we could also divide in order to get this term. And look, it makes sense because 5 times 5 gives me 5. I'm sorry, 5 times 1 gives me 5. 5 times 5 is 25. 25 times 5, 125, and so on. So my y-intercept is 1. Okay. If you want to, you can go ahead, you can pause the video and try this one by yourself. But I'm going to go ahead and just work it. So if you want to go ahead and pause now. All right, I'm assuming that you worked this problem by yourself. And we're going to go ahead and plug it again into our equation. Remember, b is what you're constantly multiplying by. So what am I constantly multiplying by? You should have said 3. So that would be times 3 to the x. A is your y-intercept. Here in this example, I actually showed you what your y-intercept is. You don't have to find it because x is already 0. So it should be 2 times 3 to the x. And this is your final answer. And then we also looked at some word problems. And my linear, I know this is linear because of the word per. I know that this would be exponential because of the word doubled. Okay? So let's go ahead and do this together. It says Charles had $3 in his bank account and earned $2 per week as an allowance. So the word per is what goes with your x. And what you start out with, that's your initial value or your y-intercept. And I like to make a notation what x means. And x is always what's after the word per or the word each. So x represents weeks. Okay, exponential. There were 3 goldfish in the tank, and the population doubled every month. So here's my equation. Remember, b is your ratio. It's what's happening. What are we multiplying by? And the word doubled means times 2 to the x. A is your initial value. So how many goldfish did he initially start out with? 3. So this would be your formula. And once again, we could note x this time, it's going to represent, it's after the word every month. So x represents month. Now, why is it important to note that? It's because if I ask you, let's go back to linear. Let's say I want you to write the equation, but I want you to tell me how much money will you have after 500 weeks. Well, that's simple. Just plug 500 into x. That's why we want to make sure we understand what x means. Just like here for this one. X represents month. Well, if I said, how many goldfish would he own if after 300 months? If, of course, none of the goldfish die, and of course they're all living, you would just plug 300 in there. Okay? All right, we also did this one, which was about Landon and 2 options for allowance. And I'll just go ahead and do this one real quick, too. So Landon has 2 options. He can either A, receive $2 per trash takeout, or he can receive 2 for 1 trash takeout, $3.50 for the second, $6.13 for the third, and so on. So part A says write a function to model each option. Well, obviously option A is linear because of the word per, all right? So that means it's y equals mx plus b. So I'm going to have y equals, my m is 2x. Now, I'm not going to have a b because if I don't take out the trash, will I have any money? No. So I'm not even concerned about initial values, all right? All I'm concerned about is just modeling an equation. So option B, now, I have to look at my numbers, and I need to look at my numbers and use that to determine, is this linear or is this exponential? Well, it would be linear if I'm always adding or subtracting, and exponential if I'm always multiplying or dividing. So let's pretend it's linear. If it was linear, I would have to add 150 to 2 in order to get 350, right? So 2 plus 150 would give me 350. So I should be able to add 150 to this next term to get the following one. But you can see that when I do that, I do not get 5. So this is not linear. So it's more than likely exponential. Now to determine what I'm multiplying by, because you might not be able to do this just in your head just by looking at it, you can always do the opposite, in which is divide. And I can take this last number and divide it by this number. And when you do that, you're going to get a decimal. And that decimal is going to be rounded to 175. And you could check. 2 times 175 is 350. 350 times 175 is going to round to about $6.13. And remember, we're rounding to 2 because it's money. So I'm just going to say f of x. If you wanted to say y, you could. Initial value, don't worry about that with this one. And we're just going to say 1.75x. Now, let's also talk about what x represents. X in this case, per, would be trash takeout. So x is trash takeout. Same thing for this one. X would be trash takeout. And this will help us with part B. So if Landon takes out 10 trash bags, how much would he earn for each option? All we would do is just plug in 10 to our equation. So for option A, it would be y equals 2 times 10, which is 20. So he's going to earn $20. I'm sorry. Yeah, that's right. So he's going to earn $20 for that if he takes it out 10 times. Option B, we're going to plug it in for here, and it would be y equals 1.75 to the 10th power. Now, in your calculator, you have something called the caret key. And caret is spelled C-A-R-E-T. It's not like a carrot you eat. But the caret key looks like this, and that just means I'm raising it to this power. So in your calculator, you would put 1.75 caret 10. And when you do that, you should get out a decimal. But remember, we're talking about money. And so since we're talking about money, and I'm sorry, this should have been point. But since we're talking about money, we're going to round it to the hundredths place. So I would get about $269.39. Okay, so part C. When does option B become the better option? All right, option B would become the better option. Would it be after the first trash takeout, second trash takeout, third, or which one? Okay, the first one, Landon is getting $2 for option A. Here he gets $2 for option B, so that's the same. What would he get for the second trash takeout? Well, 2 per, so the second one he's going to get $4 for option A. For the second one here, he gets $3.50, so option A is still better. For the third trash takeout, it would be times 3, so he gets $6. Here, it's $6.13, so this is when it becomes more, or it becomes better. So option B becomes better at the third trash takeout. And then from there, guys, it's just going to go up exponentially. All right? And one thing that we also looked at, we looked at a word problem that started off with pennies. And if you doubled it every day, you will reach more than $1 million after 30 days. So just remember, exponential always grows the fastest. Okay? Now, the last thing I want to draw your attention to is this last slide. So I'm going to skip through some because I feel like this is kind of redundant of what we did. But if you like some of these examples, pause and try to work it and compare with your notes in class. Okay. And, oh, I totally misspelled arithmetic, so should be an E. My bad. All right, but arithmetic is the same thing as a linear sequence. So in 8th grade, we talked about arithmetic. Now we can call that linear. Just like instead of geometric, we can call it exponential. So these are the same things. So if it says, is it arithmetic sequence? They can also say, is it linear? Is it a geometric sequence? They can also say exponential. It means the same thing. So that's all for today. If you have any more questions, come and see me tomorrow morning before your test. Have a great evening.